What if Lionel Messi can beat a faster defender without ever running faster than him? From a frozen image, the duel looks simple. The defender may sprint at 8 meters per second. Messi may be moving at only 7. By speed alone, the defender should win. Yet one small touch sends the tackle toward empty grass. The hidden advantage is not top speed. It is geometry. Imagine Messi and a defender moving toward the same point. Messi is 4 meters away and travels at 7 meters per second. Time equals distance divided by speed. 4 divided by 7 gives about 0.57. The defender is only 3.5 meters away and can run at 8 meters per second. 3.5 divided by 8 gives about 0.44 seconds. On a straight line, the defender arrives first. But dribbling is almost never a straight line race. Messi moves the ball half a meter sideways. That tiny displacement changes the angle of the duel. The defender must rotate his body, redirect his momentum, and travel along a new path. The length of a turn depends on radius and angle. Arc length equals radius multiplied by the turning angle in radians. Suppose the defender turns through 60 degrees, or about 1.05 radians, with a turning radius of 1.2 meters. 1.2 multiplied by 1.05 gives about 1.26 meters of curved movement. Messi's touch moves the ball only half a meter, but it can force the defender to travel more than twice that distance. Now add turning speed. If the defender covers that curve at 6 meters per second, 1.26 divided by 6 gives about 0.21 seconds. That delay looks tiny. In a dribble, it is enormous. During those 0.21 seconds, Messi moving at 7 meters per second travels nearly 1.5 meters. One sideways touch has created a forward separation almost 3 times larger than the touch itself. But that is only the first layer. A defender's full speed is useful only when it points toward the ball. The useful component equals speed multiplied by the cosine of the angle between his motion and the new ball path. If the defender moves at 8 meters per second, but the new path is 60 degrees away, the cosine of 60 is 1/2. Only 4 meters per second of his speed is now closing the gap. Messi does not need to outrun 8 meters per second. For that instant, he only needs to beat the 4 useful meters per second pointing toward the ball. Reaction time makes the geometry even harsher. Suppose the defender needs 0.2 of a second to recognize the touch and begin turning. Before the correction starts, Messi has already moved about 1.4 meters. The defender is not slow. His information is late. This creates a moving control region around each player. Its radius equals useful speed multiplied by available time. In half a second, Messi at 7 meters per second can reach about 3.5 meters. A misaligned defender with only 4 useful meters per second can cover about 2. The ball stays inside Messi's reachable region, while moving outside the defenders. The deciding condition is simple. Messi wins when his time to the new ball position, plus the time needed for the touch, is smaller than the defender's reaction time, plus turning time, plus travel time. In our example, Messi needs roughly 0.57 seconds. The defender's original 0.44 becomes about 0.85 after reaction and turning are added. 0.57 is smaller than 0.85. The slower player reaches the important space first. This is why Messi-style dribbling often uses short touches rather than huge bursts. A short touch preserves control, changes the angle quickly, and forces the defender to rebuild his path. The defender is solving yesterday's geometry, while the ball has already created a new one. So does Messi dribble with speed or geometry? He uses both. But speed supplies the movement, while geometry decides which movement is useful. Messi does not always win by going faster. He wins by making the defender's fastest point in the wrong direction.